So next term came in the thermodynamics or thermochemistry is enthalpy. So what is the meaning of enthalpy? To quantify total energy of a substance, which is not possible. So how we can do, how to quantify the total energy of the substance? So the term enthalpy is used to quantify the heat flow in and out of the system in a process that occur at constant pressure. So constant pressure means if any reaction is happening in open system under atmospheric pressure, that is considered as an constant pressure. So at that point, enthalpy is used to quantify the heat, which is Q, heat flow in and out of the system in a process. So at constant pressure, if any reaction is happening or any system is working, then the quantification of the heat, how much heat is flowing inside and how much flowing heat outside from the system, that will be equal to enthalpy. So we can also say that enthalpy is equal to heat change at constant pressure. So even I will explain a little bit more in next two slides. I will just, you can see how this statement is true. So in case of enthalpy is the internal energy plus product of pressure and volume. So how we measure the enthalpy? Enthalpy is basically internal energy E and product of pressure and volume. So enthalpy is equal to internal energy of a system plus pressure and volume. So and then when the system changes at constant pressure, the change in enthalpy delta H. So delta H is can be read as a change in enthalpy. Delta means change. This delta sign means change. So change in enthalpy delta H is equal to, when we will say how much change from the initial, then we can write delta H, and then the same equation H is equal to E plus PV, and here you can write the same equation with the change in the enthalpy, which is delta H is equal to delta in parenthesis E plus PV. And when we will open this parenthesis, this can be written as delta H is equal to delta E plus PV. And if you remember that in previous slides we have seen that delta E, which is in internal energy, total internal energy, is equal to Q plus W. Q means heat and W means work. So and work we have seen in previous video that can be written as a minus P and delta V. So we can substitute these values into the enthalpy expression. So change in enthalpy is equal to delta E plus P delta V. We have just seen this expression from here, that when any system changes at constant pressure, the change in enthalpy can be written as delta H and delta E plus PV. So delta H is equal to delta E and P delta V. Since we know that delta E is equal to Q plus W, and W is equal to minus PV. So we can replace delta E with Q plus W. So we can write, rather than delta E, we can write like delta H is equal to Q plus W, and we can also write, and we can also replace P delta V as a W. So but with the negative sign we have to write here, because delta V, P product of P and delta V will be equal to minus W. So minus W and minus W will be cancelled out. Remaining thing will be delta H is equal to Q. So this expression says that change in enthalpy at constant pressure will be equal to heat, change in heat gain or lost. So now you can understand this first sentence, that delta H enthalpy is used to quantify the heat flow in and out of a system in a process that occur at constant pressure. So if any system is working at constant pressure, then change in enthalpy will be equal to heat gain or heat loss. And there are some more important points regarding enthalpy. So enthalpy is an extensive property. It is exactly same as internal energy also. So internal energy, so enthalpy is a H and internal energy was E. So this was also an extensive property. It means they depend on the amount of material, amount of substance. Second point, the enthalpy change for a reaction is equal to magnitude but opposite in the sign for delta H for the reverse reaction. What does it means? It means if A is going to be changed into B and there is the total change in enthalpy is delta H, which is positive, because we do not write any positive sign, and just let's write here positive. And if we are going back from B to A, so the change in enthalpy will be equal, magnitude will be equal in magnitude, amount value will remain same but the sign will change. So for the reverse reaction, delta H will become negative, or if it is negative then this will be positive. So basically it will reverse. Third point, the enthalpy change for a reaction depend on the state of the reactants and the products. So exactly enthalpy, we can also say that it is an extensive property, and for the reverse reaction magnitude of the delta H will remain same but the sign will change. And third point is it depend on the state of the reactants and the products. If the state will change, so the delta H will also be changed. So let's take an example. If A and B, two reactants, are working together to form two products C and D, and the total change in enthalpy is delta H. Now you can see there is no sign, so it will be like a positive sign. And so how to calculate delta H for this reaction? Delta H will be equal to H final minus H initial, means enthalpy of the final product, and in minus enthalpy of initial. We can also write for this reaction is enthalpy of products minus enthalpy of reactants. So enthalpy of C plus D minus enthalpy of A plus B. And when delta H will be negative, it means the enthalpy of product will be less than enthalpy of reactants. So if enthalpy of reactants have higher energy, then they will lose their energy or heat. If they lose the heat, it means the system has lost heat into its surrounding, and then reaction would be exothermic. The system will be called exothermic because it is losing the heat into the system. And if delta H is a positive, it means the product have more value than reactants. So if the product have more value than reactants, it means you need to give some more heat or more energy or more enthalpy, means the system has gained heat from its surroundings. So the system would call endothermic, and this process is exactly same as your money bank account. If you are adding more money into your bank account, it means that is called endothermic, and delta H will be positive. If you are removing your money from the bank account, it means final product value will be less than the initial, so that will be called exothermic. So money is coming out from the bank account, or heat is coming out from the your system, means exothermic. So and this picture shows very nicely that your money is in the safe, and a process is endothermic when delta is positive, means when you will add money into your account, basically heat gain, so you are adding more heat into the system, your account is becoming more and more hot, so the system will become an endothermic. And if you are removing money from your bank account, means you are removing the heat from the system to the surrounding, and the process will call exothermic, and delta H will be negative. So you can understand in this way also about the endothermic and exothermic process through bank system, and how the sign will also work. Basically, when you will add anything into the system, obviously you are adding something else, anything, so it means delta H sign will become positive. If you are removing anything, you are just basically subtracting, so delta H will become negative. So next we will study about the enthalpy of reactions.